To follow along in this next video, you're going to have written the Viewport class. The Viewport class is explained in our course website. If you go to week 4, if you go to week 5, implementing a viewport, this tutorial explains exactly how to write the game camera, and you end up with a class that I have already brought into my project. So my viewport is here. It's slightly cleaned up. I have the new code standard instead of my old one from back when I wrote that article. But the logic is all the same, and I'll show you more of this in a little bit. But yeah, if you haven't yet, go read that article, follow along, write your viewport, bring it into your project. We wanted to fix the full screen mode, and I also want to check that add and remove entities from my to-do list here is actually happening. It's meant to be done in the level manager, so I'm just gonna remove this and go double check. Level manager, update, add and remove entities. So that's good. Right, we want to fix full screen. We want to bring in the viewport. And yes, one more thing, the bitmap utils. I have cleaned this up. In the previous video, it was a messier interface because I brought some of our old bitmap hacks from the utils namespace, utils class, into bitmap utils. And we don't want those things. So I've simplified the interface. I've rewritten a bit of the methods here as well. So instead of passing in output arguments, previously I would pass options into this method and have it write directly to it. I now do return values like a proper adult. I have also fixed the load subsampled bitmap, which is renamed now to be clearer, to use the in-density and in-target density arguments correctly so that the decoding step gets us to the target resolution in one go. So first it does subsampling, then it scales for us, and so what we get back is a bitmap at the correct density. If we have, if we don't want a scale with correct aspect ratio, because we can set a target width and target height separately, we will still need to do some adjustment on whatever we get back from load subsampled. So there is still a step for creating a new bitmap from that one, but the first step should now be very close. So this happens very rarely. You can put a log step in here, for example, and also put one here just to show you sort of what the target width is and what the actual bitmap height and width is at the end. Or rather, a log over there. Whatever. This is cleaned up, and so I fixed the article on the course website. If you go down, instead of calling it bitmap utils, it's now called loading large bitmaps efficiently, because that's the name of the original Google article, which you can find linked, below this video. This video explains exactly what's going on in this code. So go grab this. If you grabbed it from the previous video, it's better now, so simply use the new code. It's easier to read, and there's less mess in there. Now, full screen mode, we have already covered this in an article, so I'm just gonna going full screen and go grab this and put it in our main activity. Main activity, add an extra listener here, an override, sorry. And I know that I'm not building for KitKat or earlier, so I'm just going to remove that. Don't need the extra branch. Why am I struggling? So there we go. Hopefully that should give us full screen. Now then, back to game. Back to the viewport, in fact, while it compiles. So in the viewport, you notice I have a bunch of members. Every integer member deals with pixel values, and every float member deals with meters. Here we go. We are in sticky full screen. Perfect. So this is where we left off previously, but without the Chrome. So close that down. We have our pixels per meter. These are calculated on X and Y separately because the density of a screen can actually be different in different directions. We have screen width and height. This is the resolution of the screen, or more correctly, the resolution of our screen buffer, right? We set an arbitrary buffer because screens can be super dense and we don't want to render at those intense resolutions. Again, my phone is a 4K display. I don't need to render this game at 4K. Full HD is fine. So this will be the buffer resolution. And then we have the number of meters to show, also separate on each axis, so that we can tell our camera how much to display on our screen. And then some cached values simply for performance, because we need half of the screen in either direction many, many times. Overdraw buffer is used so that at the edge of the screen we don't suddenly cut off objects that might be straddling. We will ask the viewport to only draw things, well, the viewport is not drawing anything, but when we render, we will only render things that the viewport can see. When we ask the viewport if a thing is visible, we will make sure to take 1 extra meter into account outside of the viewport edges, and that's just to avoid flickering at the screen edge. So to set this up, when we create the viewport, we provide it with the resolution of our buffer and then the camera dimension, the viewport's meters to display, and it calls set meters to show. Set meters to show is a public method, so you can call this at any time to change the configuration of your camera. How much do you want the camera currently to show on screen? If you pass in 1,000 into meters to show X, then you will show a kilometer on the X-axis. And if you set either of these to 0, it will scale the matching value correctly, so to speak. So I can say, show me 9 meters height, and then whatever is necessary on X to fill the screen without squishing any of the artwork. So either you can set both values or one of them. Set the one you don't care about to 0, the camera will take care of the rest. Look at is self-explanatory. We will simply give it coordinates in the game world, and the camera will center at those coordinates. The most common use is that we pass in the player object. So there is an overload here that takes an entity. We will call that in every update step and just pass in our player and have the camera look at the center of the player. It is slightly jarring to have the camera follow pixel perfect after an entity, so you might want to animate this slightly, have the camera follow behind, have the camera ease towards the target rather than snap to it the way we do here. And if you do that, of course, you want the camera to animate. You might want to give it an update function, or you might want to make it a full entity. It's up to you. World to screen is the real workhorse. This is where we convert our world positions to screen positions. And as you can see, they take into account where the object is and where the camera is and how big the camera, how wide the wide port is. Don't worry about the math, read the article, it will explain it. But yeah, this is the one that we will be using a ton. Then there's a few overloads depending on what you're passing in here. In view is another of these super common calls that we will be using a lot to build our visible set. So you ask it, is this entity in view? It does a bunch of calculations and responds. Here's an obvious an obvious optimization opportunity. These values will never change in a single update step, right? So when we are looping through all the entities and asking, is this in view, is this in view, is this in view? All of these will remain the same. The only thing that changes is the entity width and height and its position. So you could potentially want to cache these results every frame. I'll leave that up as an exercise to the developer and how to implement that. And again, I have a few overloads here. So there's one taking an entity, there's one taking a rectangle object. You get the gist. And then there's a bunch of public accessors for the members that are useful. So back to the game. Let's bring this thing in. We want to create a member. So a private viewport, I'm going to call that a camera. We need a few settings, and speaking of settings, I know I left a few over our render call, so I'm just going to bring these up. They are, of course, members of the class, not that method. Just going to put that here. Going to bring that down here, because it's mostly a cache thing. That can be final as well. Pretty sure the canvas can be final. Whatever, it doesn't matter. So we wanted to give it the width and height of our frame buffer. So these are those. Then I want to also give it the number of meters to show on both axes. And meters is always float, so these will be float. Meters to show X. Let's say I want this to be 16 meters. Then meters to show Y. I'm going to set to 0. I don't care about the height. We want the viewport to calculate that for us. I don't care that much. We know that we will be using the viewport in order to calculate a visible set, so we might as well declare the visible set as well. And that's of course going to be a list of entities. So I'm just going to go to the level manager, grab one of these declarations so I don't have to type it, and then name that correctly, visible entities. I think that's what we want. So we have the game constructor. Obviously I can't create the camera up here because the camera needs some calculations. I'm actually calculating our stage width and height here. That's neat. So camera equals new viewport. Pass in order. What are the arguments? Screen width, screen height, meters to show. Okay, so stage width. Why did I call them? Oh, it's because they were called stage width and height in Flash. Might as well be buffer width and height or screen width and height, really. And then I want... Was it not camera? It was meters to show. Okay. Meters to show X. Meters to show Y. Do I have any sort of logging in the viewport at the moment? No, but I do have a toString. Good man. All right, so let's use that then. Once the camera has been created, we can do log d tag camera toString, just so that we see what we get. Now we can, let's see. The camera doesn't have an update yet. So we want to use it in, we want to tell it what to look at, though we don't really have a target. So camera look at, I would like to do level player or something like that, but since we don't have a player object, we're going to have to give it a position. Do we have, let's see, look at with 2 floats perhaps? Yep. And the level manager, does it expose a height and width? It does indeed. So we can give the game a couple of utility functions to expose here. So gonna leave this for now and go back up. Because here we have 2 translation methods, right? World to screen, we have get screen width. We can add a few other ones here that the viewport sort of gives us. And the level manager. So let's start with get world height. I'm thinking these things can be interesting for other entities, other systems to use. So in this case, we can expose some settings from the level manager. Return level. It's not level height. What did I call it? Ah, they're private. So make that public. I have no sense of decency when it comes to private and public members. So get world height, get world width. This could allow us to simply center the camera until we have the player in place. Get level width. And we might as well, let's see here, we have world to screen. And so we can use those properly with using the viewport now. Sorry, messing around. So world to screen, take a width in meters. And then I want to return. Let's change this name. World distance. to clarify. So you do world distance times camera get pixels per meter x, and then translate that to an integer because we're asking for to screen. I want a similar thing. Sorry. So, oh my god, what a mess. So return world distance y. That makes sense. And then of course we can convert the other way around by doing pixel distance divided by pixels per meter. So I'm gonna just invert these to do something like screen to world. So that's important if you have, say, finger touch or want to get a pixel value from the layout system and you want to translate that to our world. So we have screen to world. This is an integer for screen distance. Pixel distance. It should return a float. This should return a float. Actually, I don't dare keep these as integers because every time I work with integers and floats, I tend to do integer math by accident. So I'm just going to make sure that these, because it's clear enough that this is pixel distance. So we want to do pixel distance divided by the camera, and then pixel distance divided by. So world to screen is world distance times, and screen to world is pixel distance divided by the factor. That should be right, and if it isn't, we will notice when we get this thing running. So a bunch of accessors that will be useful. Let's go back down to the render, or rather the update. So for camera, I might want you to look at level width divided by 2 and level height divided by 2. So we just center the camera in the game world, right? Now for the rendering, we want to make use of this thing. Actually, let's do this properly. Let's build the visible set now using the camera, because we have this thing here, build a set of visible entities. So once we've updated, let's do build visible set. Private void, build visible set. The work we want to do is first do visible entities clear, because this needs to be reset every frame. Then for final entity E in our current levels entities, which has just been cleaned out, remember, update has made sure that it's despawned whatever needs to be despawned and added whatever needs to be added, so it should be in a good state. We look through each entity and we ask if camera in view our entity, push back that reference. Visible entities, add. And that's pretty much it. That gives us the visible set. So at the end of our, let's see, update, build visible set, we want to render. Instead of passing in the entire list of entities, pass in visible entities. And again, a bit silly, right? Because visible entities is a member, but if we want to move render out to a separate thread, a separate class, whatever, having it as an argument is useful. I might actually want to have visible set take an argument and return it, but whatever. Now then, to actually use the viewport, I want to I need to translate things using the camera. I thought I had a cheat sheet. Give me a second. No, well, whatever. What we need is first a point object, because I don't want to generate new objects constantly. I don't want to make these separate values. We're gonna just use the override from, let's see, where am I? I'm in the level manager. I want to be in the viewport. If I go to world to screen, this is the method I want to use. It takes a point object where it writes the coordinates we want to render our entities at. So we need a point. Let's go back to game. Let's make this private static final point object. Should I call that render at or just position? Position is good. Position isn't very good. Well, whatever. Do new point. Then, instead of doing this stuff, we ask the camera, world to screen, pass in the entity, pass in the position. Then we do post translate on the position. That should be it. Blah, 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 blah. We reuse that thing. Let's see if this works. It's a building. Yes, it is. Oh, there we go. And we seem to indeed be centered on the world. Now, my assets in this world, if I look at the test level, here we go. They are not exactly centered, but we could try to change where the camera is currently located, because it's now centered here. If I wanted to, I could put this at, say, up the top left corner. That should move all of our entities over to the side. So one thing to keep in mind, now we are focused, the center here is at the top left corner, 0, 0 of our game world, so all of the objects in the game world is to the right. So if we had edges in our game world, you'd notice, of course, that our viewport can go outside of the game world. And that might be fine, but it might also not be what you want, in which case you're going to have to come up with some logic to, if I just make a frame for a game world here, you can absolutely add logic to your viewport so that it's always kept inside of the game world. That can be a good addition. Let's see here. Go, go, go. So here's our little game world, and that's the center of the screen. So what we want to do now is probably add dynamic entities, and then let the camera follow those, and then we want to add controllers. So we want to have dynamic entities, the player, and then controllers, so that we can start building some gameplay here. That's going to require some collision testing and such, of course, but we can do that. All right, let's see you in the next video.